This video will discuss how we use the Fisher Scientific calorimetric thermometer to effectively measure the heat of a solution of water and potassium nitrate. We can start here at the machine with the computing side of the instrument as well as the actual experiment side. We used the computing part to first find the IP address of the device and connect it to a computer. This was used so we could actually obtain data. If you would be to connect this Ethernet cable to a wall plug, and then connect this Ethernet cable to the same wall plug, and connect this piece to a laptop, you would actually have an IP address that you can obtain here. You would then be able to go to a browser, put Microsoft Explorer Windows, and input this specific link to actually get to the page that would contain your run's data. During our runs, this was a point of extreme technical difficulty because rarely would it update properly. However, we did find out that by shutting off and rebooting the computer, it would usually fix this issue. To actually test the heat capacity of water and potassium nitrate, we needed two things. We needed to fill this bucket with some water at various temperatures, and we also needed the potassium nitrate. The water aspect of the experiment was fairly simple. We would take an Erlenmeyer flask, we would fill it with water, and then we would either heat it on a hot plate or cool it down in an ice bath. We would then take the water and weigh it out on either an analytical or an ordinary balance to obtain precisely 100 grams. We would then take that 100 grams of water and pour it into the bucket of the calorimeter. The solid part of this experiment, the potassium nitrate, would be loaded onto this Teflon cup in the plunger setup. This would then be lowered in, and it would be spinning through this rubber band. The potassium nitrate would be weighed out to 2 grams plus or minus 0.1 gram, so fairly high precision on an analytical balance. Once the potassium nitrate was loaded into the Teflon dish, it would be pressed up and sealed within the glass container. This now allows for the top lever to be pressed down, which would pop the cup open, and it would disperse all of the potassium nitrate into the bucket with the hot water, warm water, or cold water in it. For any given run, they were also recreated using a material called tris and hydrochloric acid, so this would match any cold water, hot water, warm water runs that we did. This was to serve as a standardization and a backplate for us to compare whatever we got from the actual water testing to. Next up, we will discuss how to properly use this calorimetric thermometer with a loaded sample and water to actually get your data. All of these steps can be found in the lab notes. However, we will still give a quick demonstration of what we would do. The first step in the procedure is to go to Program Info and Control, go to the Software and Hardware Info, and we would be finding the IP address. This would be hidden right above the MAC address where it says no network. It would show a network if we actually plugged it into the Ethernet system and into a computer. The next step was to go to the Diagnostics tab. Within Diagnostics, we go into Data Log. Within Data Log, we go into selecting what we're logging. In this page, we want to ensure that tsum and t1 have log in their corners and everything else has a negative sign. We will now go back to main menu. The other thing within Diagnostics that we want to look at is specifically within Data Logger, and it's the interval, log file destination, and the log format, which should be in accordance with what is shown on the screen here, unless your lab instructions say otherwise. The next directory we want to look at is to go to Operating Controls, and within Operating Controls, we want to look at the jacket temperature and source. In here, we want to ensure that the jacket temperature source is calculated. The next point of our interest is to go back into Diagnostics again, and this time we're going to look at the calorimetry parameters. Within the parameters, we are interested in the tolerance parameters, and we are looking specifically at L2 to ensure that it is set to -1. The last step was to go back to Diagnostics, back to the data logger, and just to delete any remaining data log files that were in the system. This would allow us to start on a clean slate for the next logging. We will now consider what the steps would be if we had a run prepped. So, should there have been water in here, and potassium nitrate in the cup, we would have placed this into the instrument, into the container, connect the thermocouple, which is what actually measures the solution temperature, and sometimes you'll get an error that pops up on the screen. This has never given us any trouble besides the fact that you just press OK in the bottom corner of it and move on with your experiment. The next step is to connect the belt to the top of the engine, the motor, in the back, and then just to place it over your sample, the gear on top of the sample container, or the plunger. Now usually, once this starts spinning, it will rock a fair bit, so you can either just hold down or tape down this edge, and it should prevent excess motion. To actually start this, we would ensure that we go to calorimeter operation, and then we would enable the stirrer, which would cause the motor to spin and this thing to spin. Then we would look at the temperature graph here, which, ignore the jacket temperature. We have no idea why, but it just reads whatever the heck it wants. We are more interested in the bucket temperature. Now, as per our last experiment, you can see that it's currently calibrated to be between 60 and 40 degrees Celsius, which means any normal water temperature would appear too far below on the graph. To change this, we would go to the setup of the graph, and we would look for the bucket max value and the bucket minimum value, in which are customizable. That's the only thing that's worth changing on this to not mess up every other operation. Using escape, we can leave the graph, and we can consider the rest of the experiment. Once the stirrer is on, we want to usually leave this stirring without hitting the top and starting the reaction for about 5 minutes. This lets the temperature of the water acclimate with the temperature of the metal and get nice and even. This is also why we have the stirrer on and the temperature graph, but also the data logger on, because this will allow us to actually register the bucket temperature. So, provided that all is well, this is spinning, it has sat for 5 minutes, you've watched your temperature graph finally stabilize in red, you would simply pop this down and let it keep spinning for another 5 minutes. If you observe on the graph, you should see that the temperature, which would normally be a fairly straight line by this point, would either dip or spike according to the reaction and whether it's endo or exothermic. Lastly, to clean up, we would simply remove the thermocouple from the plunger that's in and place it elsewhere. That works. We would then remove the plunger, and usually there will be some solid residue inside of the glass container, so you'll have to get at that with a Kim wipe and some DI water. You can dismantle this whole setup, and you can run water straight up through the pipe and even through the top if you remove the glass rod. This bucket is fully removable. You can just take it out and dump it into any waste container that you have on the side. After that, due to technical difficulties, we would usually end up restarting our computer once we got the data file, and then we would be able to get a clean slate for a new test run. This was the largest bottleneck in terms of time, as it took us 2 lab periods to finally find a solution to getting more than 1 run a period.